All right, we're live.
All right, so they all there now? Assignments. Scroll down to presentations. I should totally move that to the top so I don't have to look for it. January 27th. Download.
Oh, yeah. I think he also pays on the Wi-Fi also goes to the server. Professor, we just use it.
Yeah, we'll see if it's there. If it's not, we'll drag in. Let's go. It's taking forever. You don't want to be on my camera. Group 1, Group 2, Group 3, Group 4, Group 5. All right. Group 1. I think. Just go to YouTube, make sure we're actually live. Yours, yeah. All right. So don't forget to talk to the camera / microphone.
Okay.
Yeah.
I'm standing here at the 5. Just like, it's kind of cute. All right.
We're not trying to win any YouTube awards.
Yeah, we'll take over that.
It doesn't see you. You're standing there. You're
Yeah.
off,
I'm out
off
of camera.
camera.
Here we go.
All right.
All right, so we're Group 1.
Might as well stop it.
Oh yeah, I will start mine. Here's a group of guys that are working on. So as we showed you last week, this is our plan for our schedule for our planning for the whole term, pretty much. If you go one more time. This is about where we are. So we're still in the same, roughly the same spot we were last week. Still working on planning out the CNC stuff and eventually working toward within probably the end of this week into next week. We'll be working on actually making discrete files for this.
Yeah, so this overall assembly consists of a handlebar, the handle mount, handle link, the handle itself, the body assembly, there's a sliding jaw, the cage, and pins. Some of these parts are already updated, but we just didn't update the full assembly. But overall, it's going to look like that.
So this is one of the parts of it. This is the handlebar. So this is the big part that goes from the actual crushing mechanism to the handle. So our plan right now is to use a 20-inch by 4-inch aluminum bar as stock material. This is a larger part, so we're still deciding whether we're going to make it into multiple pieces or machine it as one. So then we're going to start with facing it just to clean up the sides. Then we're going to pocket those holes at the bottom, contour to get the outline of it, and then chamfer to deburr it.
Yeah, so this part's the handle mount. There's going to be a little bit more design work with it. We may go with a square kind of structure instead of this kind of curve just to make it easier. But for all the stock material, it'd likely be an aluminum bar or plate. Since the max dimensions are about like 5 inches by about 6.5 by around 3, so that's likely what the block of stock material is going to be. For the tooling, there's a 3-inch face mill, a 3/8 end mill, and a 1/2-inch end mill. So we're probably going to face it to finish off the surface, the pocketing operation for the holes, and probably the inside curve, or we might make a square kind of shape, and then another pocketing operation for the holes using the 3/8 end mill. And so this part's the handle link. This actually connects the handle to the sliding jaw. It's likely going to be a aluminum bar or plate again, probably 1.25 inches by 6 inches by 1.75. If we need to like round out, it might be like 1.5 inches by 6 by 2 inches, and then we can cut off the extras. For the tooling, another 3-inch face mill, 3/8 inch end mill, and 1/2 inch end mill. For the operation, same as the other one. Facing operation, pocketing operation for the holes, and then a contouring operation to cut out the link, and then a pocketing operation for the inner channel. We wanted to ask the professor about this. Would that be kind of the best way to do this part? Because so what we're likely going to do is going to cut out this, drill the holes, cut out the link, and then rotate it, and then cut out a channel. Would that work? Would that make sense?
The bit in the middle that connects the two pieces
Yeah.
there, does that go all the way to the bottom?
No, it's like it's like just in the middle. It's like
So you're gonna
you're gonna have to rotate
you're
it
gonna have
twice.
to flip it at least twice.
Yeah.
So it's possible.
Okay.
Um,
We may have to thicken the walls a little bit just because they're like at this point they're about like like a quarter of an inch thick, but we may make it a little bit thicker.
Also, real quick, this is Zach. He's also one of our partners in description. But anyway, the next part is the handle. This should be a pretty simple turning operation. So, plan to bore out the center hole, turn down the outer diameter. Should be pretty simple. We were thinking about having like a beveled handle, but we decided to turn it to just a straight turning operation to make it simpler.
Yeah, so this is the main body assembly. It's going to consist of 4 total parts, with 2 duplicate, but a bottom, 2 sides, and a mounting plate. The stock material will likely be a 1/2 inch aluminum plate. We're thinking probably like around a 2 foot by 2 foot big plate, and we'll cut out all the pieces. For the tooling, 3-inch face mill, 3/8 end mill, and then 13/64-inch drill bit. This 4/4 20 tap.
what's the face mill gonna do?
Because these plates are like probably around 10 inches, not 10 inches, 10 millimeters. So that's about less than 1/2 inch. So we're just kind of facing it off just to make it the right thickness. Unless there is 10 millimeter thick plate that we don't have to.
So what'll happen when you take a what'll happen if you take a flat plate and then run a face mill across it? The cutting force from that face mill tends to be up. So what it's going to do is it's going to try to lift that plate in the center. Then you're going to have to hold it down like on the corners or something like that. And so very often in that situation, you may get like chatter in that plate. So it's not impossible. It's possible to do that. That operation isn't trivial. You're better off if you buy material that's the thickness you want. With that said, then you may want to have a machine surface on that. But if I did want to have a machine surface on that, I may use a smaller tool so I'd have less cutting force. At a 1/2 inch thick, it probably is strong enough to withstand that lifting force anyway. If it was a 1/4 inch thick, I would say don't do it. It's just gonna vibrate like the top of the drum. On the table.
Do we have like 10 millimeter thick plate available? This stock?
Absolutely not. Did you price that stuff, or did you just?
Not yet, but I know we just kind of looked at like Home Depot or wherever just to see if it exists or not. So, so then, I guess I'm not sure if we'll go with the facing operation, but we'll be drilling and tapping the holes for the assembly, and then pocketing operation for the pinhole, and then contouring for the outline.
The next part we were doing would be like the sliding jaw. We'll be using aluminum as the material again. For the operations, we're going to face and square up all 4 sides of it, drill holes and counterbores, and just cut into the inner chamber. And the cage for the cans to go into, the stock material we're using this time would be acrylic. We'll be trying to use 10 millimeter thick, or any thickness would work. And the operations we'll be using are drilling and tapping operations and contouring to cut the outer walls, with tooling being listed.
Drilling and tapping the acrylic together. It might be easier if you're just using acrylic just to do tabs. So you're not, because it cracks super easily.
Yeah, I think it might be easier.
You may want to laser cut the acrylic instead of CNC machine it.
Yeah, we thought it'd be easier than just to go instead of aluminum, so we can see all the cans because that's where we stack them.
Yeah, that's a good idea.
Yeah, so then we're gonna have a couple pins. We thought instead of turning them down, we could just purchase them. We found a couple parts in a MasterCard. We have one that's 10 millimeter diameter and then two 50 millimeter diameter. They're about 480 a piece on average, made out of 52-100 alloy steel. We thought that was cheaper than like 316 or 18.8 stainless steel. So we have a link over there. They'll probably be around 100 millimeters of length, which is about 4 inches, which is, if we need to turn it down, we'll try to make it thinner, or not thinner, I mean shorter. And then for the next step, we would order stock material and pins, finalize the method to secure the crusher to the surface. Because right now we just have that plate in the back. We may use a plywood board and mount it up against that. When finalizing designs and change dimensions on parts, depending on parts being ordered. I know there's the link and the long handlebar that we may have to redesign or finalize, and then we have to plan out which group members will be focusing on which parts, so that everyone has their own schedule. Go to the shop and machine those parts, and then refamiliarize ourselves with the spring, because it's been probably around like 3 years since we've used it. So
that's pretty much about where we're at in our project. Any questions or suggestions?
Excuse me. Why did you guys choose like pins instead of just like commercially available like bolts that would probably do the same thing?
I mean that might be easier actually to use the the bolts in that, but I think because already the assembly had pins, it might be.
Yeah, from the CAD drawing that we had in our CAD, so we just kind of went with it.
But yeah, I mean it's probably a good idea actually to use bolts. Probably easier. We might have them already.
For joints where stuff rotates, right?
Yeah, it'll be like where the
You
handle.
don't want to rotate around a thread on a
Thread,
bolt,
yeah.
so if you're going to use the bolt, though, you'd want to use a shoulder bolt.
Shoulder bolt.
So yeah, it depends on the placement.
That'd actually probably be easier than trying to just put a pin in there and make it stay. You know what I mean? To have like if you thread on both sides, or if you use the shoulder bolt and then actually tighten it down on one side.
Yeah, it's going to tighten down together
Yeah.
onto that shoulder.
Onto the actual part.
Or
the assembly.
yeah, you need to have that as part of the design.
Yeah.
It allows you to take it apart and put it back together. If you have press fit pits, it's harder to take it apart and put it back together. Also, you need tighter tolerances to get the press fit to work right.
But I mean,
any other questions from the class? Any concerns about any of the parts that they had and whether or not their method for making it's a good idea?
I think Professor mentioned it, but the 1/2 inch thick for that like housing seems like way overkill. Like if you wanted to do 1/2 inch, keep it that way for like structural support in like critical areas, and not do like 1/4 for the whole thing. Like I would suggest seeing if you could like do some sort of like a pocketing operation with some like ribs maybe, because it's going to be really, really heavy.
that's true.
That's a good one.
Yeah, if this was a design class instead of a computer-aided manufacturing class, I would be questioning your design choices for the materials and the thicknesses also. So that's something you should consider. It's not something I'm going to be a stickler about because that's not the focus of the class. But yeah, any idea how heavy this thing's going to be?
Yeah.
Pretty heavy.
It's going to be pretty heavy with like 10 millimeter thick plate all the way around. At least it's not steel.
We have a stay away from that.
So if you needed the strength from that material, then it's absolutely right. If you pocketed inside there and you made ribs in it, because you don't need the strength from the plate You need the strength from sort of members to go together. That's a design thing.
Is that
I do want you to make sure you know the cost of the materials. I think you're going to find that some of that material is going to be expensive. It's stuff that we may not have on hand, so we may make some material choices based on that. Anything else? All right. Then I thank you, and pretty much right on time. We're ready to start group 2.
Cool.
Zach and
Mustafa.
Mustafa.
Oh, well.
can you put up the notes? Lovely.
Are we?
Yeah, which mic is the one we need? It's
Talk to the camera.
That.
Okay, lovely.
We can change the height of the camera too.
Yeah, my sleeve.
Just point it.
I'm too short.
Yeah, we got height issues up here. It's understandable.
Shorty squad.
It's all right. You're gonna be cool, like the stars that come up on stage for musicians and stuff. They always have to adjust the mic stand and everything. So yeah, the mic's built into the.
Lovely. All right, so we're group 2. I'm David.
I'm Noelle. We're making a chess set. This is a CAD model of all of our lovely chess pieces. Some design notes. We are going to be, in order to kind of broadly categorize the heights of the different pieces, we are going to be setting 3 heights and 2 base diameters. The pawns are going to be 1.5 inches tall with a 3/4 inch diameter. The middle height pieces will be everybody except the king and the queen, and that'll have a 7/8 inch diameter and will be 2 inches tall. And the king and queen themselves will be 2.5 with a 7/8 inch diameter.
We kind of chose those numbers just because the way we wanted to work this out was rather than have one person design all 6 chess pieces and have like a more uniform design, we kind of wanted everyone to be able to have one design of their own, so we kind of could have our own little like contribution to the project. But standardizing some of the heights and the diameters will make it look a little bit more uniform together, I should say. These are all of our tooling selections for like our turning and milling operations. Like we said last Thursday, our team's going to be using the mill turn machine, and we'll talk about that later in the presentation. So we're basically going to be using every turning tool that we have available in the shop, the 55 and 35 degree inserts, the grooving tool, and the cutoff bit, as well as for some of the parts, we're going to be using them like some light milling operations with the 1/8 inch end mill and a 1/4 inch end mill.
And so thus in turn, these are the turning feeds and speeds that we're going to be using for each of the different tools and materials. We again are using 2 different materials, brass and aluminum. And this is information.
Yeah, we broke it down all into a table. That way when we go to start making all of our Esprit programs, we have like a nice concise
reference sheet.
Yeah, for all of our feeds and speeds and everything.
And the same goes for the milling operations. The 2 milling tools we'll be using are the 1/8 inch and 1/4 inch end mill. We will need to go to Novo. I don't personally know who Novo is, but for materials other than aluminum because we are using brass.
Like we said before, we're using the Haas mill turn machine. We're going to be using that says 3-inch bar feeder, but I'm pretty sure it's supposed to say 3-foot bar feeder. Both?
Up to 3 inch diameter.
Oh, that makes sense. So the bar feeder is pretty useful for us because it's going to allow us to not have to like refixture stock material into the jaws every piece we make. We can just feed more stock into the work area and start cutting the next bit or next piece. Like
you can read all of those fun statistics at your leisure.
And this is more information about the materials we're using. Our stock material is going to be 1 inch wide, which is why our base diameters are slightly less than 1 inch. And we're looking at $45 worth of aluminum and $200 worth of brass. And that should cover enough for the pieces that we're making, as well as enough to like hold it in the additional tooling allowance.
Yeah, the quick math based on the heights that we set puts us at just under 36 inches of total piece per side, and factoring in mistakes and fixturing lengths and other things, like just double that, make it about 72 inches. You can buy 6 feet stock lengths pretty readily on McMaster. And those are the pricings right now on there. And that's it. Any questions, comments, concerns?
Thoughts, conspiracy theories? Cool. Thank you. Oh, yes.
Actually, sorry, I do have one. This isn't necessarily like in a big ring project, but if you have brass and aluminum pieces, they're all going to be different weights between the two. If you want them to be similar, you might consider like drilling out the center of the brass pieces below the weight. I don't know if you really care if they're the same weight on each side, but
Thank you though for that's I actually didn't know that, so that's very good input. I'm not if we are going to be considering weight, that would be something that we would need to discuss with the team. Because as far as right now, it's just to look pretty.
I actually would have gone the opposite direction. I would have said instead of aluminum, use stainless steel, so they'd be closer to the same weight.
I didn't know brass was that heavy.
Me neither. But yeah, that is a valid point. Thank you, both you and Professor, for pointing that out.
Of the parts you're making, how many of them are mill turn parts, and how many of them are just turning parts? Looks like the rook. Sorry,
The pawn and the bishop, I think, are the only ones that aren't using mill turn.
okay.
Yeah.
But like this will be a small mill turn or mill operation, as like these little cutouts.
In the face of the night.
Yeah, those will be little.
So the people that are designing those parts in particular, think about the size of tooling and the reach that you're going to be able to have, especially for the 90-degree angle tools.
Yeah.
So just make sure that as you're designing those parts, you've considered what tooling is convenient to use in that machine, so that you just don't make features that are hard to make. That's my advice.
That was one of the questions I actually had about that machine. So how many axes does like the mill spindle have in it? Is it like just Z?
So so Z is aligned with the spindle, the rotating spindle.
Okay.
In any lathe. So Z is in and out of the spindle, and X is front to back if you're standing in front of the machine. Y would be up and down if you're standing in front of the machine.
Okay.
And so a regular turning operation only moves in X and Z. That makes sense?
Mm-hmm.
And so when you you could put a milling tool that comes out from the face of the turret. So it would operate on the face of the workpiece. So you could put a milling tool located in that orientation, and you could do Y operations. You can rotate the workpiece while you move an X also. So you can do all that. We also can put a milling tool that's aligned with the Y axis.
Okay.
Or I guess it's aligned with the X axis, but it doesn't matter. It moves an X and Y and Z also.
Okay.
So, but you're going to be limited by the number of tool holders you can fit in the machine at any point in time, and whether or not they interfere with other tools that are in the machine. I don't think you're going to have a problem with these parts, but it's something to be considering while you're designing it. So we could have 2 90-degree tools. We can have 2 face tools, and then we can have some limited number of regular turning tools. So I would set up a time either with myself or James early next week, to just get sort of an orientation of the machine and learn how the tooling works and everything. So that, and especially whoever's going to be designing those parts should be included in that. And that way you can get a good
Go through editor
feel for that. And if we're on the ball, we'll make a video of that introduction and then we'll make it available to the whole class.
Awesome.
Lovely.
Thank you. Any other thoughts? Cool. Thank you for listening.
So we've got a little bit of extra time as we switch to the next group here. So I just want to make a comment. So by tonight, we got to hand in all those quizzes for each of the presentations. For each person has to do that. If you don't have a question that arose yourself when you're watching this the first time, write down a question somebody else asked, because we do take off points if you don't ask a question. So saying I don't have a question isn't a valid response. Likewise, feedback for the group. If you don't have any feedback, listen to the other feedback and copy that down. Because it's totally okay to quote my question in that statement. If we didn't have some sort of mechanism for grading the quality of those questions and that feedback, then it would be really easy to just answer the quiz questions without having even watched the video of the presentations if you weren't here. And so that's the purpose for that, is to make sure that everybody's actually paying attention to all the groups, and we can all learn together through that feedback. So we're group 3 is ready to go. So who's been getting the fancy sort of pointy masks when they go to get their COVID tests? Like the white ones, the KN95 ones that go down like this. Anybody? I really like those masks for everything except talking. I tried to give my ME3820 lecture yesterday wearing one of those masks, and I'm not sure any of the noise came out. I mean, I had the microphone down here, so maybe the people online can hear me. So that you guys can hear me, I have the cheapo kind of mask on today. Hope nobody gets COVID from it. All right, you guys can start.
Okay, so we're group 3. We're doing the hand car. I'm Amber.
And I'm Bradley.
So we're gonna start with the stock pieces that we're planning on buying, and then we'll explain what we're gonna do with them in processes. So we're planning on getting a 1/4 inch round stock 6061 aluminum. We need 2 feet for axles, and then 1/2 inch round stock of 6061 aluminum, about 2 feet also. And then we're planning on getting a square foot by foot 1/4 inch sheet of aluminum. And then we were thinking that maybe to cut down on the cost, we'll be able to access some of the shop materials. I'll get rid of that. There we go. And then for parts that we actually need to buy that we can't make, we need a couple bearings for the axles for the hand car to actually work. The total cost would be about $100, $101 with McMaster. If we were able to 3D print the base, we could lower that to $76, and that would replace some of the aluminum. So that cost includes a 1/4 inch, 6 inch by 6 inch sheet.
So for the processes for the axles, we just want to use the round stock and then just put it on the bandsaw to size. So the wheels, we want to actually cut these out of the aluminum sheet. I forgot to update that, but we want to cut these out of the aluminum sheet, and then potentially double that up if we need extra thickness. And then for the frame, we're either going to do a wooden frame to cut down on costs, or cut out the outside supports with the sheet and just kind of weld it together somehow. And then we could also potentially 3D print the frame. All the linkages would be wire EDM for the most part. And then the gears would also be wire EDM, and those would come from the sheet as well. And any type of pins would just be lathed from the round stock.
So things that we need help with, we need to kind of review how to do wire EDM. We also wanted to ask you if it would be okay to 3D print the base to cut down on costs. We didn't know if you wanted us to machine everything.
I mean, part of this is to decide what's the right process.
Okay.
It's if 3D printing is the right process to make the part that you want, then yeah, that's totally okay, right? That's still computer-aided manufacturing.
Okay.
Right? Because I mean, they still use computers.
Yeah.
If you wanted to make it like out of a sheet of plywood, you could laser cut it to have the design you want. It also depends on how you wanted to do that. Because you can, or never mind, I'll let you finish.
Okay.
Then we can.
So yeah, 3D printing the base would cut down on cost a lot. It would be a lighter design and way quicker. And then money, I didn't know if we had some sort of budget or something to stay within, or how we go about getting materials.
First step is figure out how much it's going to cost.
Okay.
The next step is then we'll figure out how we're going to do it.
Sounds great.
So there's no fixed budget. And there's probably no money available, but I'll tell them that it's a safety issue and that they have to do it.
Sounds good. And then we just wanted to look at the inventory in the shop and see what we have to work with. So this is our CAD model of the hand car with all the linkages. As you can see, it's just showing you the different phases. So this is neutral, and then when one side is raised and when the other side is raised, and it would just rotate this gear down here to rotate these wheels. These would spin freely. And also, like, to cut a lot of the cost, we want to use like one sheet of 1/4 inch and take a lot of the wheels and such and cut them out of the interior of this frame so we can get the most out of our material. And a lot of the linkages would be able to be cut along the side with the sheet that we selected. And that's our presentation.
Any questions?
Just curious, did you make the assembly?
I did.
Cool. Other comment is, I think you could definitely laser cut that base frame. That looks like something that could very well be suited just to be cut out of wood. If it's not strong enough with 1/4 inch piece, you can always cut 2 and just glue them together. I think it would be a lot faster than 3D printing too, and cheaper, I think.
Anybody else?
What was the size of the base?
So this is 5 inches by 12 inches, so it's going to be just a small decimal.
Any more questions?
What's the diameter of the wheels again?
2 inches.
You had said you were gonna wire EDM the gears and the wheels, or just the gears?
So I think the gears, we were originally thinking the wheels just to get these sharp edges right here on the joints, but I think that CNCing the wheels could also potentially work.
Yeah, I did some wire EDM over the summer, and it's like pretty not easy. So I would just like say you should plan for like not just one messed up part per good part, but like maybe 3 messed up parts per one good part.
Kind of in the same vein, I was wondering like how you guys, a lot of these, some of the gears and the wheels look pretty delicate, at least also the scale that you're working at. I was wondering like how you guys are planning on keeping it accurate and basically being able to make them in a reliable and consistent way.
Yeah, so I thought about that a little bit, and I think that just for cost reasons, we're going to try to just keep everything thin and then just use shaft collars to keep it tight and aligned. And a lot of like the gears, if we need more surface area to mesh, we might double up the gears and just print like 2 gears, hopefully if the wire EDM works, and just kind of mesh those together and have a 1/2 inch gear.
Are you using like pins to keep everything together, or do you plan to like kind of screw everything together too? Some of the parts of the assembly.
So we're planning on pins, but then we can also just thread those, and if we need to, just thread them in.
For the dry axle, I can't really tell. Are you using a hex shaft or a round?
Yeah, so I didn't put in that height shaft, but this one here.
Is it a hex? Okay.
Yes. All right. Thank you, guys.
I have a task for your group. Okay. For next Thursday's meeting, have made the prototype of this using just a laser cutter. So get a piece of 1/4 inch plywood, and use the laser cutter to cut out all the pieces, because all the pieces look like they could get cut out of a piece of 1/4 inch plywood, right? Definitely. Cut out all the pieces from a piece of 1/4 inch plywood, except for, I guess maybe the round pieces wouldn't be. And assemble a prototype of this. There's probably some little dowel pins or something in the shop where you can use. Push this together, but make a prototype of this completely out of 1/4 inch plywood for next week, and then based on that, decide which parts you want to explore machining, which parts need the wire. So the precision on the wire ADM is, it will hold the tightest tolerances of any machine that we have, for sure. So I wouldn't worry about the precision there. But as to the time, so we'll set up a couple groups that need to do wires. So let's do a thing early next week where we invite people in for like a demo of how to set up and get a quick run through of the wire ADM. Yeah. So we'll send an announcement out to the class and try to get somebody from each group that needs to use the wire to be there at least, and we'll make a video of it so everybody can see it. But one of the things that's going to come up is the time to make this on the wire. If you were to cut out all those shapes, so I imagine it's about 10 minutes on the laser cutter. Once you've got it all set up to just run the thing and cut it out based on the amount of the distance it needs to go. The laser moves a lot faster than the wire does. The wire moves really slow. So that's a thing.
Anything else from the group? Are you guys familiar with how to use the laser cutter? You know how to do that?
Yeah.
Okay, cool.
I was gonna say, if not, you can figure it out. Many people have. All right, good. Does that size correspond with any train set thing that you could buy?
I didn't look into that.
You may want to scale it so that it fits on like an H or an HO scale train track. You know, people have those. But once you've got it figured out, you can scale it, so it's fine. 4.
Hello, we're group 4. I'm Trevor. This is Nate, Igor, and Patrick. And we are working on the root style supercharger. Over the last week, we had to edit our models a little bit. Our end caps are now going to be made out of acrylic and are going to be laser cut. Our screws have changed a little bit, and we have taken the top off of our casing in order to be able to let it be seen.
So with the casing, there are a few options that we have. On the left here, I have sort of the biggest size model that we were thinking about doing. There are a few issues that we might run into this. This is going to be a fairly large piece of stock if we're going to make this full size. So it's going to be pretty expensive to get. And it's also just a lot of material to remove from that. That being said, fixturing is going to be a bit easier. The other option that we were exploring, we're doing 2 pieces, like one on the right that we have there. And obviously there'd be a corresponding piece that was mirrored. And in that case, we'd be using the acrylic end caps to hold them together. So obviously the stock would be a little bit less expensive for this. The fixturing would be a bit more difficult, I think. And it's also not going to be quite as precise when it's all bolted together. So there are a few considerations that we have there, and we haven't quite decided exactly what we want to do with it yet. For the gears, so I have a model there on the bottom right that shows essentially the supercharger, but without the gears. There would be 2 gears that mesh on the ends of those shafts, and the points of those are to keep the screws meshing properly. We are most likely going to wire EDM the gears. We were discussing this a little bit. We're going to need to find a way to mate them to the shafts so that they rotate as one fixed piece. The shafts were likely going to be pressed into the screws. We were probably going to get a keyed shaft and make a small keyway into the gear. One of the issues that we might experience with that, though, is that we'll need to make sure that the gears and the screws can mesh properly at the same time when we assemble them. So if it's all press fit together, we're going to have to make sure that there's proper angular alignment there.
So the screws we're going to make out of 100 millimeter round stock that we're going to turn down from 4-inch aluminum stock. We're going to put the stock in the lathe first, take it down to that 100 millimeter dimension, and we're going to drill a hole through it for fixturing in the 4th axis.
When looking at the materials that we would need for the screws, we would need 4-inch by 2 feet 60-61 aluminum round stock. For the base casing, this was one that we looked at a few different options, but we ended up going for 2 3x4 blocks of aluminum, and they're 6 inches long. And the end caps are going to be made out of acrylic. They're just going to be laser cut. The gears are going to be 1/2 inch thick 6x6 plates, and the shafts are going to be 20 by 400 millimeter keyed shafts.
Yeah, so as far as our process plan is concerned, obviously the screws, as I mentioned, we're going to turn down to 100 millimeters, which is like 60 thou under 4-inch, which is pretty convenient. So we'll just need to do a finishing pass on that, and then we're going to face off the end and drill a 20 millimeter through hole, and probably ream it so that the shaft is a good sliding fit on that, and then we can glue it in and probably get our angular location correct that way. And then after that, we'll put it in the 4th axis on the mill, and then we're going to rough it out with a 1/2 inch end mill, and then we're going to do our finishing pass with a 1/4 inch ball end mill. As we mentioned, the gears, we plan to wire EDM the tooth profile, and then probably drill a center hole and broach a keyway so that they can transmit power to one another. And then the end caps are going to be laser cut out of acrylic sheet. That's going to be 1/2 inch thick on either end total. And then the shafts, we're just going to cut the length and face both ends. The base, we're still trying to figure out how we want to make it, so we don't actually have a set process plan for it right now. We'll be able to figure that out as we determine the best way to manufacture it. And these are the speeds and feeds we found for the operations we're planning. And that's the presentation.
Any questions?
Sam, what size is it gonna be? Like,
so each,
like just the whole thing, like together. Like,
If you had to buy a shoebox to put it inside, how big would the shoebox have to be?
The case, I believe, is 6 inches deep. That's its longest dimension. I think it's also about 6 inches wide and 3 or so tall. I can't remember exactly what the measurements were, but something like that.
Okay.
The gears obviously are going to add a little bit to it, and the length of the shafts also, but those are separate parts.
yeah, and then the diameter of the screws are going to add some to that as well. So.
Would you like to make the case out of high density polyethylene?
Good. Wouldn't be opposed.
I have a box full of it. You can have some.
That's cheaper than a big piece of aluminum.
Yeah.
It'll be the same machining processes.
Mm-hmm. Yep. Do that.
Okay. So you're gonna want to set that up as like a 3-axis operation.
Yep.
In the mill. I would recommend getting started with that code right away because you probably haven't done a lot of that lately.
Yep.
Any other questions? So on your shafts and your rotors, you could build a machine out of one piece. You could turn down the shaft diameter and the rotor diameter, right?
Yep.
You could then use that turned down shaft diameter to hold it in either the fourth axis, or you could make the whole thing into a turn machine in one setup.
Do you think we'd run into rigidity problems?
There's a tailstock there too.
Okay.
So you could turn down the smaller diameter. You could actually machine the keyway in it at that point when you're doing it with the mill turn machine. So that may be another way to make the part so there's fewer pieces and really one setup for each part.
That would probably be good because then we could get our angular location of the keyway relative to the rotors.
Exactly.
Yeah.
It would be because it's all one setup. You get all that stuff in one go. It'd be really cool if the case could be entirely clear. I don't have any of that material.
That would look cool.
Anything else? Then I guess we're up to group 5.
How's it going? Yeah. Cool. Hi, everybody. We're group 5, and we're the puzzle group. So, I'm Nick.
I'm Brian.
So we have a pretty exploded view of our puzzle. Basically, this showing all the parts. So I don't know if we can come back to that. How about?
And so we were figuring out how we're gonna machine all these pieces. These we figured we can just throw in the mill. In the dimensions that we're showing, we're working on scaling it down from the original size to decrease cost.
So we're ahead of schedule. You could probably just go to the just log into Google and open the presentation directly. So I'm guessing that it's a video file that's in your Google Drive.
I guess.
So you can just log in. Just go to the browser and log into Google, and then you'll be able to show the videos.
Ryan, what's your last name?
Pacheco.
What's not to try to guess your password.
That's frustrating. Cool. Let's give that another try.
That way we get to do the presentation.
So there's a good amount of parts on this.
Well, now you're teaching us how to solve the puzzle.
If anyone can remember for this, that is a bonus because we had the CAD model up yesterday and we were still having problems putting the puzzle together. So it's a pretty difficult puzzle. So there's like 15 different parts. There's maybe like 18 total parts. There's a couple duplicates in there. So it's a pretty complex geometry on some of them, but some we can get away with some pretty simple setup and machining. So we're on this. So actually the original puzzle was pretty large. We scaled down all the dimensions since its original. So we scaled everything down 25%. And these dimensions shown represent the 3/4 scale. of the original. So we still might scale it down more if we have to, but here we are. So those were just a couple of like note pieces. A lot of our parts have some sharp internal corners we'd like to try and maintain. We talked to James in the shop and got a recommendation to mostly mill some of the outside shape of the parts and wire EDM the internal corners. So a good amount of parts in our puzzle, we plan to do that process.
Yeah, we want the puzzle to be able to fit well together, so we don't want the rounded edges. We want to get as precise as we can to the actual model that we have. And then, so this, we were concerned with the rod on the staircase piece because if you go all the way around, we don't want it to snap off, and then there would be no connection between this and the hole. So we figured that we can just machine a hole through, and we will turn a rod in the lathe and secure that in there. We'll mill both of these. We'll use a wire EDM for the sharp corners on the bottom piece.
Yeah. So this is the most complicated piece, and it's also our biggest. So there's some more investigation needed for the right number of setups and all the operations that need to be done on this. But it's likely between mill and EDM. Some things we learned, the wire EDM can't go not all the way through the part. So these square pockets right here will have to be filleted. We might be able to EDM the through slot in the middle there, and use a few different setups to try and mill some of the other geometry on it.
And so we went into Washburn yesterday to look at the available stock they had. A lot of the ME3820 aluminum can work for a decent amount of the parts we have, such as these, but we were going into Big Mastercar and looking up prices of these. So for all of these, scaled down, would be about $70 for 3 feet.
For some of these other pieces, we need a little bit bigger and more square stock than the regular ME800 bars. So we have a 2-inch by 2-inch and a 2-inch by 4-inch set of stock here. And the little rod we want to machine on the lathe, it's so small. It's like a 1/2 inch long by like less than 1/4. If we can just source a little bit
Could
of.
it be a 1/4 inch?
What was that?
Could it be a 1/4 inch?
Totally could. Yeah, just make it bigger.
Just get it out.
Okay. Yeah. So that'd be even easier.
Yeah, and then we're just looking at, these are 2 of the largest pieces, so we need a big piece of stock for these. These are more of the pricey ones, so that's why we're looking at scaling it down a little, see if we can get these prices down.
Yeah. So pretty large stock for those. So we just took a couple pictures. This picture on the right was a pretty large piece that we found. It could fit ours. We didn't want to claim it at this stage of the game, but just to put it in the brain of whoever we may ask permission, that might work for us. So that is, I think, all we have.
Is that wood or is that some weird coloration?
It's just weird coloration. Yeah, it's all aluminum. We're just planning on 6061 for ours.
Yeah.
Same thing. A lot of places will put stock on the end to quickly know what grade of material it is. So from a distance, if you've got a rack full of different grades of material, you can see from a distance how much of each type you have. And so I'm sure that's why that was painted that color.
One other note, so we went to Void, or not Void anymore. anymore. The Innovation Studio this week to print our puzzle.
The building formerly known
The
as
building,
Rosie.
so yeah. We realized the part whose CAD we used didn't have any tolerance built in, so we had a pretty hard time squeezing it all together. So there's a good amount of data on hole and shaft tolerances for fits. We're not positive at this stage if what literature is available for like non-circular parts, mating parts, like slots and things like that. But we have to investigate further the clearance that we need to put the pieces together.
So you can extrapolate from that data, and what I would do is take the width of the slot, the two sides that are confining it, and just call that the diameter.
Okay.
And then that'll give you the over under for that type of fit for something sliding in that slot. That's the typical way to do that. If you have a weird shape and you really need to know, you have to do an experiment and figure that out. Okay. But you could use the shaft data and you could actually add those things together. So you could stack up the errors or the allowances to figure out what it needs to be, even for odd shaped parts.
Yeah. Cool. Okay. Yeah. So any questions?
Anything else?
So one thing up with the wire EDM, I think what you guys were saying is possible with like the really sharp corners. The thickness of the wire is, I think, 10 thou inches, and it cuts it a little bit more than that. But when you're cutting like the outside corners, you can get those pretty much dead 90 degrees. The inside corners, then you'll have a radius of about 5 thou. So on the when you're doing like the spree code for the wire EDM, those internal corners, you can just make, instead of the wire going straight 90, you can just do like a little indent in a little bit, so you'll be cutting away more material than you need to. So that way the 90-degree corner, the part that's fitting in, isn't gonna touch the part there. Does that make sense?
Like drilling the corners on a
exactly
fixture thing and then fit. Okay. Yeah, that's.
But it'll be really small, like barely noticeable even, so you can still get that same look.
Do you need to change the geometry for that in the file, the CAD file, or just do it as well?
That's the easiest way to do it.
Okay. Yeah, we did talk to James, and he recommended we reach out to you for wire EDM training of some kind of investigations.
Go back to the hard part.
Yes.
So you can make those features with Synchro EDM.
Oh.
Yeah, Synchro.
And so the way the Synchro EDM works is you machine an electrode that is the negative of the shape you want. So you make it like a square boss. And then just like with the wire, it uses a high voltage differential between the wire and the base plate to basically vaporize the material as the wire moves through it. And so the Synchro works the same way. It comes down and vaporizes some material, comes up, comes back down. And so the electrode wears out and the part wears out, but you can probably make those features with the square internal corners with the Synchro. I recommend shrinking it again.
Okay.
Make and that'll make, it'll make all the EDM cuts faster because they won't be as long.
Yeah.
It'll make it easier to source the material and find the material. And I think it'll fit in your hand better when you're playing with it.
It'd be kind of heavy in this point too.
Yeah.
I don't know. Maybe if you were like the abominable snowman or something, this is the right size. But I think for us normal humans.
Cool. Yeah, that's fair.
But yeah, so I would. Have you used the Synchro?
A bit.
People in your group know how to use it.
Yeah, we use it a bunch for that.
Right. So he can help you with that too.
All right.
Yeah. Thank you, guys.
Thank you.
All right, that was all the groups, right? We finished. All right, you guys clearly didn't follow the instructions because it had time slots for how long your presentation was supposed to take, and some of you went too fast. I'm going to move this so it doesn't fall over.
And I'm gonna fix this because I'm cool. All right. So I had a couple of general things to talk about, and then we'll probably end a little bit early today. Woohoo! End early. Is that good for everybody? So I don't want to jip you on time. I get paid for the time. I will stay here and do stand up if that's what it takes. All right. Let me. So on the let me check to see if the YouTube's working anymore. On the weekly presentations, I like what we've been doing. I think we're getting some progress. I will. So which I gave a group an assignment, group 3, right? So you guys are assigned to use a laser cutter to make a version of this, make all the parts. I think you can probably find some dowel pins down there to use to pin the stuff together. When you're going to use, or some screws or whatever. So make a very rough, you could even use cardboard, right? You could even use cardboard instead of the plywood, but I would use plywood. Just make a version of it because your parts are very well suited to cutting with that method. I would also say for your thing to make the whole thing out of aluminum. The best process would be to either send it to a shop that had a better laser cutter than us, or get a water jet cut, just because of the shapes. So when you're looking at these parts, you want to consider what do the shapes look like. And what are the best processes to make this part? The puzzle group. Who absolutely has to use the wire EDM? Puzzle group needs to use it. You guys were thinking to use it for your gears. The gears for, so that's 3 groups. The chess piece group does not have to use it, correct? What about the Cade Crusher group? You guys have gears in that? No, so you don't have to use it either. All right. So let's make a time early in the week to get you guys so that you can make a simple part there. Doesn't need to be one of your parts. But let's get everybody so that they have made a simple part on that wire EDM this week. Does that make sense?
Everyone make an individual one.
Or each group make one part, right? So represent each group. So that's 3 groups.
Yeah.
And if we can organize to meet a representative from each of the 3 groups all at once, then it could be one time of teaching them, and then everybody schedule some time to use the machine. I'm guessing towards the end of the term, scheduling that machine is going to get really busy. So if you've got your design finalized, on those, everybody's making gears that has to use it right now, not the puzzle people. But the other 2 groups, the reason you were using it was to make gears. Find out how much it would cost to buy those gears instead of cutting them, because that's a valid engineering choice too. Yeah.
Your recommended source, because we were looking on
Smallparts.com. And who was ever on a First Robotics team? There's lots of places that sell stuff like that, right?
Max Robotics, Andy Mark, West Coast Robotics.
Andy Mark, that's what I was thinking of.
Mitsubi or something like that.
Yeah, but there's a bunch of companies. So actually, if you like Google search like First Robotics gears, that'll probably bring you to a bunch of places that sell stuff like that. So that's a good source. But yeah, the Vex ones too. I like the idea of the hex shaft, and you get the gear that's got the hex broach already, so you don't have to do that. So there's a bunch of projects that have to transmit torque, right? So the rail car thing, you've got to transmit torque from your gear to your shaft, or between the 2. From this to one gear to the other gear to the shaft that drives the wheels, and then from the shaft to the wheels, right? So you're going to have a feature that's going to transmit that torque. What are the possible ways that we can transmit torque from the gear to the shaft? What could we do? There's a question for the class. So you could. So one of the groups talked about doing a keyway, right? That was the roots group, the supercharger group, right? So you talked about doing a keyway, and so you get the round shaft, and you basically mill a slot on the radius of that round shaft, and you have a piece of material that fits in that slot, and then in the gear or the wheel or whatever you're putting on there has a notch cut out of it that stuff fits in. So when you slide it all together, that key locks it in place, right? That's what a keyway does. So if I make this go up, room control. Room control. Stop sharing the screen too, right? I have to go over here and stop sharing the screen, I think.
We just take the aluminum too.
Screen share. Okay. Say again with the aluminum question.
Could we just take weld the shaft?
So you could weld the shaft to the gear, right? If they're both the same material, you could weld it to that. I just want to. So if you've got so here's your shaft, and you cut a little slot in your shaft, and then here's the hub of whatever goes around it, and you cut out a little mating thing, right? And then the key goes in there. The two slots there, those are called the keyways. And so to make this shape here, you can broach that. And so broaching is pretty much just taking a piece of material and shoving it through the other material. So push harder is how you do that. Now you try to have it remove less material and stuff like that. But if you're cutting the gears in the wire EDM, then when you cut the outside gear shape, right, you can also cut the hole in the center with the keyway in it as well, right? So you do that all in one setup as a thing. So that's another way to look at that. So putting a key and keyways in your parts, that's a way to transmit the torque. How else could we transmit the torque? You said weld it together. So you could weld it together. That's a semi-permanent solution. Yeah.
You could use like a set screw.
So we could have our shaft, and we could have the hub of our gear or whatever it is here, and then you'd have it like the gears out here, right? And so you could put a threaded hole in that hub and put a set screw that pushes against the shaft. What's the problem here? Yes.
If the shaft doesn't have a flat face, that's gonna slip around.
So if you do it just like this, it's just the friction between the bottom of that screw and the shaft that transmits the torque. And so it could pretty easily slip on that. The other problem with this is this force here pushes the hub that way, right? Wants the hub to move that way relative to the shaft. So you're no longer spinning on center. That may or may not be important to you, but it's a thing. So it's something to consider. You can avoid the slipping part by putting a flat on the shaft. And now you've got, well, you can draw the free body diagram, right? But you got more mechanical advantage to resist that rotating. Doesn't mean it can't rotate. It just means it's harder for it to rotate, right? You could put a flat on your shaft and put a flat in the hub. So you can make like a D shape to transmit that torque, right? And so then it just still slides on. The advantage of the set screw, once you slide it on, is it doesn't move this way either. Well, I mean, it has the same ability to not move that way. One of the groups talked about using shaft collars, right? So that'll keep it from sliding sideways on the shaft pretty well. But it doesn't really help it to transmit the torque. I mean, there's special ways you can do it, but they all involve something like this, right? What else? So certainly know by next week how you're going to transmit the torque on all the things that need to transmit the torque in case you need to work that out, in case you need to do something special. You guys had your hand up.
I didn't know if you were asking for another way to transmit.
Oh, go ahead, yeah.
Shear pin.
Right, that's my snowblowers. Oh, snowblowers use those, right? I mean, my snowblower uses grade 8 stainless steel bolts, but that's just because once I lose the shear pin, I have to go find something else to shove through the hole to make the snowblower rotate. So you can use a pin. Actually, my my garden tractor had a setup where there was 2 shafts that came together. One of them had a like a collar attached to it, welded around it, so it would slip over the other shaft. And there was a shear pin that went through. And I guess the previous owner had gotten tired of replacing that shear pin, so he just welded the shaft, so it was welded on both sides, which made it much harder to remove. Because the reason you want it is so you can like take it apart, and to actually pull it out of the flywheel assembly in order to take it apart. But driving up a hill this summer, the weld broke, and suddenly I was rolling back down the hill, not driving up the hill anymore. So, all right, so that's why I said semi-permanent, the welding one. Go ahead.
Is it using like stainless steel, like really grade A stainless steel, kind of pointless for a shear pin?
I don't want that thing to stop spinning. Yeah, no, it'll damn it breaks something else. The reason you put the shear pin in is because you want to control the point of failure. And you want it to fail at that spot so that it doesn't break something more expensive upstream. So yeah, that it's a bad idea to use the high grade stainless bolts, but that's what was laying around. I've also used 16 penny nails and just keep driving them in until they don't fall out.
Just a question is, if we wanted to machine like keyways, just like this is a wrong project.
Yep.
But would you have to use like the lathe and then the mill turn thing?
No.
Or you fixture like a round?
You can fixture a round thing in a mill, and you can put a keyway slot in it. That's pretty common. I was just for that particular project, I was thinking you could do the whole thing in one setup without having to take it out. That was my thought. So just like the D shaft, you can put a hex shaft. Well, I can't draw a hex, but you get the idea, right? So you'd have a shape that will allow it to transmit the torque. Those hex shafts are readily available, and you can get gears that have the hexes already in them. And then you have a little set screw that keeps it from sliding from side to side. So look at those catalogs. If you're making gears, look at those catalogs to see could you buy the gear. I'm not going to say we will buy the gear, but have that as an option. What else did I miss? Was somebody at home? Will any edges?
That was on the puzzle people.
Oh, puzzle people. Yeah, they want to know, are you going to relieve the edges so that knock off the sharp edges so that people don't like have to get bandaged after they put the puzzle together?
The outside edges, we haven't talked about that, but probably.
Yeah. Put a note on your drawings that say break all sharp edges.
Yeah.
When we were in Washburn, we were discussing like if we had like pretty tight tolerances, it could just put together and look like one piece of metal, which conceptually that kind of sounded pretty.
That would be cool. Make it work the other way first.
Yeah.
Before you try to do that. I've seen stuff like that. And that's certain. I've seen wire EDM parts where when they're pushed together, you can't tell that it's 2 pieces, then you pull them apart. Right? So you can totally do that, but make it the easy way first.
Yeah.
That's my advice. Supercharger group. Have a plan for the 3-axis machining of the base thing for next week. And come meet with me either late in the day today or tomorrow to figure out if that material I have will work for your base piece. Puzzle group. Have a plan for whether or not you're going to be able to use that sinker EDM to make that hard to make part. Oh, and for your rod that sticks up, use a dowel pin.
Yeah.
Press the dowel pin and it stays on one side and it comes off the other side.
Yeah.
So tolerance it so it's a press fit on the side it stays in and a slip fit on the other side.
Do you want us to look at like GDT at all, or maybe like actual engineering?
Well, you're going to have to, because that's what's going to make your part work, right? So you're going to have to at least get the numbers right. It's not critical for grading of the project, but you're not going to be able to make your part unless you figured out what all those dimensions and tolerances need to be. The train group has an assignment. Your group has an assignment. What crusher group? What are you guys going to do for next week to move the project forward?
Could try to prototype like a body part, because I know a lot of the parts are like they got a plate. Maybe we could like laser cut and just kind of make like a video.
You might be able to laser cut a prototype of your entire mechanism also. Do that. See if you can laser cut a prototype of your entire mechanism and that'll be good. The crusher group was group 2's the chess guys, chess people. Make sure you learn about the tooling for that, for the mill turn, especially the radial tools and the face tools, and prepare a part of your presentation next week to teach the rest of the class what the limits are. So like the reach, how far you can do and stuff like that, to make sure that the whole rest of the class gets exposed to that, especially the roots guys, because they may need to follow you. You may need to teach them how to use the mill turn stuff. Which group didn't I give an assignment to yet? Does everybody have something special to do for the next one? Okay, now everybody in the group, so all the groups, have your first slide of your presentation. Say what we did this week. What we did this week, what we're going to do next week. Problems we had this week. And how they get solved or not. What do you need? You know what? We'll make a template for what the first slide needs to look like, but it's going to have this information. What we did, what's next, problems, and how they were solved if you did solve them. What help do you need? Yeah, anything missing that everybody should report? I think that's it. Okay, that'll be the first slide of each presentation. We will send you a template for copy and paste for that slide so that they will all look the same, so we can compare one to the next. Yeah.
If we're ever like stuck on this question, should we?
Don't wait.
What?
Yeah, don't wait if you get stuck on something. Often I'm there. Certainly, if I'm out walking around the lab, just ask. If you don't see me, you can't, or I look like I'm wicked busy and I really don't want to talk to you. You know, I can turn that face on and off. It's usually on, but I can't turn it off. So just pop on and make an appointment, or grab James, or grab Hayden, or grab any of the PLAs that work in the lab. They may not know how to solve your problem, but they may know somebody that does. So yeah, don't wait. Certainly don't wait until the next Thursday to ask the question. Anything else? Let's go. Let's have fun. That's it. So everybody have fun, but not so much fun that somebody gets arrested.